Okay, so the first video in our fraction series is going to be adding and subtracting mixed numbers. Adding and subtracting mixed numbers. So you guys, as 7th graders, should have come in with some knowledge about fractions. We're not going to spend time on just adding a fraction and a fraction together. We're going to talk more about adding mixed numbers together. That way, basically you're going to have 4 examples and we'll go from there. If after this lesson you're still not sure about how to add and subtract mixed numbers, it is totally okay. This is just a review and we're going to continue learning the rest of the year. So don't worry if after this lesson you still don't quite have it, okay? Feel free to pause, feel free to rewind whenever you need to. So the very only most important thing that we're going to remember when we're adding and subtracting mixed numbers is that we always, every single time with adding and subtracting, we always find a common denominator. That's going to be my only step for these questions. Always find a common denominator. So the very first thing I'm going to do, I'm going to split my page into 4 because I'm going to do 4 examples, and hopefully during those 4 examples, you'll be able to kind of see the process of what happens each time. So the first example that we're going to do is 3 4/5 plus 9 2/3. You're going to see me write them this way first so that you can see the original problem, and then you're going to see me write them up and down. I personally prefer to write them up and down just because I think it's a little bit easier when we are working with fractions to write them that way. So this is going to be our original question, and then I'm going to rewrite 3 4/5 plus 9 2/3. Okay, now notice the 5 and the 3 are not the same. So when it says find a common denominator, currently we do not have a common denominator. That's exactly what we're going to need to do first. So part of this is knowing your multiplication facts, right? 5 and 3, basically, if you don't remember your multiplication facts and you can't decide what common denominator to use, all you do is just multiply those together. So 5 times 3 is 15. So 15 can be my common denominator, right? So basically what I'm going to do is I'm going to make these into equivalent fractions that have the same denominator for both fractions. Basically, one of the biggest rules with fractions when you're finding a common denominator is whatever you do to the bottom, you do to the top. Okay, so I'm going to change colors so we can kind of see a little bit differently. So to get from 5 to 15, 5 times 3 is 15. So whatever I do to the bottom, I do to the top. 4 times 3 is 12. Okay? Same thing. Whatever I do to the bottom to get from 3 to 15, 3 times 5 is 15. Whatever I do to the bottom, I do to the top. 2 times 5 is 10. Okay? At this point, I have a common denominator on both. So now I can either add or subtract. So there becomes a point where this right here, this step then, is no longer needed. And you don't have to mark it out, but just know that now this is 3 12/15 and 9 10/15, okay? So what I would do next, because I have a common denominator, is add those two things. So 12 plus 10 is 22. Never do I add denominators. We worked really hard for that common denominator, so it's still gonna be 15. And then 3 plus 9 is 12. You've probably noticed something a little bit strange about this answer. This fraction is improper. This is what we call an improperly mixed number. So it's a mixed number with an improper fraction in it. We can't leave it like that. So what we need to do is change this improper fraction back into a mixed number. So some of you can do that in your head. Some of you can figure out how many times 15 goes into 22 in your head. But in case you can't, we're going to do some division. Top in, bottom out. 15 goes into 22 one whole time. And 22 minus 15, there's 7 left over. So here's what that means for our answer. That means that this fraction actually has another whole number with it. So this fraction is no longer part of our answer. This is another whole number, so I'm going to add that to my 12. The 12 is going to become a 13 because I had 12, and now I have one more whole, which makes 13. And now there's 7 pieces left, that's my remainder, out of the 15. Okay, and that would be my final answer. This is probably the most complicated type fraction question as far as adding fractions in 7th grade that you're going to see. If I really wanted to, I could have changed these two fractions to some decimals. They wouldn't be pretty decimals, this one wouldn't, but I could at least get an answer that would get me close. But for right now, we're working on fraction operations, so we're gonna leave them as exact fractions, okay? All right, let's go to the next example. It's gonna be 12 and 1/2 minus 3 1/4. 12 and 1/2 minus 3 1/4. This one's gonna be a little bit easier for us. So we'll start with 12 and 1/2 minus 3 1/4. And remember, I have to have a common denominator. I don't just yet, so what I'm gonna have to do is create a common denominator, just like we did over here. In this case, we could just multiply 2 times 4 together, and our common denominator could be 8. That absolutely would work. What I want to encourage you, though, is to think through the smallest number that these have in common. What is their least common multiple? In 5th grade, you probably called that the LCM, right? Least common multiple. 2 times something can actually get me 4. So I'm going to use 4 as my common denominator here. I think that's going to be the easiest. All right, so whatever we do to the bottom, we do to the top. 2 times 2 is 4. So 1 times 2 is 2. This one was already in fourths. 4 times 1 was 4. So this one stays the same. 1 times 1 is 1. Once I have a common denominator, then I can either add or subtract like I need to. In this case, it is subtraction. I would say be so careful. Many times that we just assume every problem is addition, but this one's not. So this would be 2 minus 1. So that would be 1 left over. And we still, again, we never add or subtract denominators. So that's 1/4. And then 12 minus 3 is 9. This is simplified, so this is actually our final answer, 9 1/4. Okay. We're gonna do 2 more questions, both of which are gonna be subtraction because we gotta talk about some borrowing. And again, if you are confused at the end of this video and you still don't understand it, it is okay. We're gonna continue to work on these questions for quite a while, and fraction operations are gonna continue all throughout 7th grade, so we'll get lots of practice, okay? So this one we're gonna do 11 1/3 minus 10 5/6. 11 1/3 minus 10 5/6. So we're gonna start with 11 1/3. I'm gonna rewrite it, 10 5/6. And that's gonna be our subtraction problem. Again, the very first step, always find a common denominator. These guys do not have a common denominator right now. Again, if you cannot find one, you're welcome to do 3 times 6, and your common denominator could be 18. I wonder, though, if there's something smaller that we could possibly use. So think about the least common multiple between these two. If you aren't sure, you also can use your multiplication table. That's a really good tool for you, is to use a multiplication chart. So if you have one in your journal, that might be a really good tool for you to use. I think that my least common multiple is going to be 6. Because 3 times something gives me 6, and I know that 6 times something gives me 6 as well. Like we said, 3 times something gives us 6, and 6 times something gives us 6. So let's talk through that. 3 times what gives me 6? Well, 3 times 2 is 6, and whatever I do to the bottom, I do to the top. So 1 times 2 is 2, okay? Same thing on the bottom number. 6 times what is 6? 6 times 1 is 6. Whatever I do to the bottom, I do to the top. So 5 times 1 is 5. Here's the problem, okay? The problem here is that now I do have a common denominator. However, 2 minus 5 I cannot do. If I have 2 things, right, and I try to take 5 from that, that's not mathematically possible unless we go into the negative, which in this problem, that's not what we're talking about. So just like in a regular subtraction problem, I'm gonna have to do some borrowing. So I wanna give you an example of what I mean, okay? In a regular subtraction problem, if we have, let's say, 43 minus 17, okay? I can't do 3 minus 7, so I have to borrow from the 4. The 4 would become a 3, and because this 4 was in the tens place, that means I borrowed 10 things. So this 3 would then have 10 more, and it would be 13, right? We've been doing this probably since 2nd grade, okay? So this borrowing scenario is the same thing that we're about to talk about right here. So just keep that in mind, okay? So I need to borrow from the 11. Just like normal, the 11 is going to become a 10. Okay, here's the difference. I'm not borrowing 10 things because these are not cut into pieces that have a 10. I'm borrowing 6 things, right? So I'm borrowing, the 11 became a 10, I'm borrowing 1 whole. In this instance, the 1 whole looks like 6/6, right? 6 divided by 6 is 1. That's the 1 that we borrowed, okay? To do that, that means I have to take the 2 I already had. I'm adding the 6 that I borrowed, and that means I have 8 now, okay? So I'm gonna put this right here so we have a little note. 1 whole. This is your 1 whole. If this part confuses you, here's a secret. You take your numerator, you take your denominator, you add them together, and that gives you how much you have to subtract now. So 2 plus 6 is 8. Okay, now I can do some subtraction. So 8 minus 5 is 3. We're gonna keep our denominator. It's gonna be 6. 10 minus 10 is 0. If you wanna write the 0 there, you're welcome to. I don't think we need it though. And now 3 and 6, we know that they have a common factor. I can divide 3 and 6 both by 3, and I get 1/2, okay? 1/2. Again, in a regular scenario, let's say you have a word problem that has answer choices. Could I have taken these fractions and changed them to decimals and maybe worked that way and done some estimation? Yes, okay? But this process, we just want you to be able to see this specific process. There is another way to do this as well. So if you wanted to take both of these numbers and again, turn them into improper fractions, you'd still have to find a common denominator. So I know that's a way that some teachers teach this specifically, but what we found is that when you're doing that, those numbers get really, really large because again, you're still having to find a common denominator, okay? Let's do a little bit different one. Again, we're doing 4 examples. Each 4 are a little bit different. This one is gonna be 19 minus 5 2/7. 19 minus 5 2/7. I'll tell you exactly what people are tempted to do, okay? They're tempted to just bring this 2/7 down right here. Exactly tempted to do that. However, this is nothing, and I can't take 2/7 from nothing. This isn't an addition problem, this is a subtraction. So this is like saying 0 minus 2/7. So just like over here where we had to borrow, we're gonna have to do some borrowing again, right? So the 19 is gonna become an 18, and I need to borrow 1 whole, right? I need to borrow 1 whole from my fraction or from my whole number, okay? So 1 whole, in this case, it has to be something that equals 1 whole. We like to call it a onesie sometimes, right? Because it represents 1 whole, a onesie, right? And in this case, we're gonna have to have a common denominator. So I'm gonna go ahead and use the 7 because I'm gonna have to have a common denominator. So what number could we put on top that would make this equivalent to 1 whole? Well, think about over here, we used 6/6, okay? Maybe some of you might say we could use 2/2. Is that 1 whole? Yes, absolutely it is. However, that's not my common denominator, right? So I wouldn't want to use that. I could use 3/3. Again, that's not my common denominator, so I might want to use something different. Hopefully at this point you know we would use 7/7. 7 divided by 7 is 1. That's where that 1 whole came from. 1 whole. Okay, 7 minus 2 would be 5. So I can take my numerators now and subtract. Never, 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 never do I add or subtract denominators. So it's gonna stay 7ths. And 18 minus 5 is 13. One of the biggest mistakes that people make here is maybe they do this whole process exactly correct and they forget to mark out their 19. So they might get 14 5/7. Okay? So one thing I want to just remind you of, no matter what type of fraction, addition and subtraction with fraction problem that you're doing, always, always find a common denominator. Again, if there's any one of these questions that you're still stuck on, really all we're asking you to do is practice, and we want to just see where you're at in this. We're gonna do a lot more of these throughout the year, okay? So don't be discouraged. We definitely want to see all of your work and your steps so we can know exactly where to help you.